Okay, so yesterday we have looked at how to write the codes for single ODE. So I hope you guys can try by yourself how to uh, code for this kind of ODE. There is an example here, but we will skip this exercise for now. We will come back later. Okay, so for today we will go into doing code mallet codes for systems of ODE, meaning that more than one ODE. So yesterday we have code for ODE, a single ODE, but for today we will go into learning how to do how to code for systems of ODE, meaning more than one ODE. So the most common example in biomechanics or biomedical engineering is what we call van der Pol equations. So van der Pol equations are equation to model the oscillator or something that oscillate. So the application usually in the modeling of action potential in neurons or the electrical signal in the heart, for example. So all of this using van der Pol type equations. So the most common van der Pol equation is given here. dy1 dt equals y2. dy2 dt equals 1000 times 1 minus y1 squared times y2 minus y1. Okay, so let's say you are given this kind of equation and your initial conditions for y1 at time 0 is 0 and y2 at time 0 is equals 1. Okay, no parameters. Parameters are already given its value here, 1000. So for system of ODE, we code as the same step as yesterday. So first thing is you need to write the function of the ODE. Okay. So function dy dt. So let's say we give the function name cuba 9 for example. So the input is t and y. Okay, so so first we look at the ODE. Okay, since there are two ODE here, dy1 dt and dy2 dt, so you need to have your dy dt here as an array. Okay, two times. I mean array with dimension 2 because you have two ODE. So yesterday your array is dimension 1, okay, because you only have one array. But for now you have two equations. So you have dy dt as a dimension 2 array, okay. So the first thing you need to do is from the example you have to write dy dt equals zeros to 1, okay. So this the purpose of writing zeros here is to create empty array, okay, or empty matrix. So sometimes in MATLAB, when you code something that is require a lot of lines of code, sometimes MATLAB might confuse. Maybe there are some codes that are not deleted or remains in that array. So you need to always empty the array, okay? Empty the array first before you continue your calculation. So the purpose of putting zeros here is to create an empty array. So meaning that to clear the array, okay? And then after that, you need to write your equation, your ODE. So since you have two ODE, so first you have to write dy dt1, and second one is dy dt equation number 2. Okay, so let's write equation number 1 first. So equation number 1 says dy1 dt equals y2. So you simply write dy dt bracket 1 represent the first equation. So here dy1 dt equals y2. So what you need to write is y bracket 2. Okay. And then for the second equation, so the second equation says dy2 dt equals 1000 times 1 minus, so y1 you write y bracket 1 squared, so squared times y2 minus y1. Okay, so since this is a multiplication operation, so you need to have dot here, okay, dot star and dot power. So here y1 represent y1 in the equation, and y2 represents y2 in the equation. Okay, so why we have bracket here? Because now your ODE is in terms of array. So when it in terms of array, you need to call uh, which row of your y you are going to use. Okay, so here you are going to use the second row, but this one you are going to use the first row of y. So the first row is y1, the second row is y number 2. Okay. Okay, so this is your ODE equation function, ODE function, and then you can solve save first. Okay. Now you can write the calling function. Okay, function. Okay, so the first thing you need to write in your calling function is the initial condition and the time span. So initial condition y naught equals, so since you have two initial condition here, so you need to create an array. So the first one is 0, second one is 1. Okay, so this value 0 here represent the initial condition for y1, and 1 here represent initial condition for y2. So the question doesn't give the time span, so you need to so usually you will be given time span, but here dia tak bagi, so kita assume je lah from 0 until 3000. Okay, so after you state your initial condition and time span, then you can write your ODE solver. So ODE 15S. So first thing you need to call your ODE function, which is cuba 9, and then put your time span, and then put your initial condition, and then you can see. Then we can try solve this. Okay. Okay, so you get your time and your y. So you get two value of y. Okay. The first y1 and the second column is y2. So from here you can plot your y graph. Okay. So the example given here, it plots for y1. Okay. So it choose only the column 1 here. Okay, so this is the result for y1. And you can also plot for y2 if you want. So we put color red, for example. Okay, so y2 is tak penting sangat. So macam garisan je. So the important graph for van der Pol equation is usually the y1. Okay? So the important things of modeling a system of ODE is that when you have more than one equation, so what you need to write is dy dt1 represent the first equation, dy dt2 represent the second equation, and so on. Okay. Okay, so let's look at an exercise. Okay, so another example of system of ODE model is Lotka-Volterra model of chemical reaction. So you have learned chemical reaction back in matriculation, STPM, masa SPM belajar, dekat poli ada kot, form 3 pun ada, kita belajar pasal chemical reaction in chemistry. Tapi kita tak belajar macam mana nak tulis equation dia. Okay. So in chemistry also there are a lot of ODEs involved. Okay. So it requires software to solve ODE equation in chemistry. But example given here is Lotka-Volterra for predator and prey equation. Macam example, kita nak tengok interaction between rabbits and foxes. Dekat satu kawasan, kalau ada rabbit, kalau kita letak seekor musang, apa terjadi dengan population rabbit tu? Berkurang ke? Makin banyak ke? Kena makan ke? So kita boleh modelkan guna Lotka-Volterra equation. So another example of Lord Carbonera equation is tadi chemical reactions. So example is when you have chemical reaction that involves multiple steps or multiple reactions. Like for example here, A bertindak balas dengan X menghasilkan 2X. So how to model this? dA dt equals minus K1 AX and so on. Dalam exam tak adalah dia tanya untuk tulis equation. So usually you will be given equations in exam. So example here, A plus X becomes 2X, and then X plus Y becomes 2Y, and then Y untuk satu tempoh yang masa yang lama dia akan jadi B. So here you have A, X, Y, and B. You have 4 different variables or 4 different ODE equations. So example that we tried just now, you have 2 ODE only, but here you have 4 ODE. Okay, so here you are given the equations of the 4 ODE. So mungkin dekat rumah kita try, I want you to try to write the ODE function for this 4 equation. Boleh cuba tak? So boleh cuba dekat rumah untuk tulis the codes for this 4 equation in the ODE function first. Okay, only write this function. Okay, you don't need to write the calling function. Okay.
Sir, okey tak tu, sir?
Okay, so for the first equation, you have dA dt equals minus K1 times A times X. Okay, so before you write the code, you need to define to yourself what is Y1, what is Y2, Y3, Y4. Okay, so here we assume Y1 is A, Y2 is B, is X, Y3 is Y, the big Y here, and Y4 is B. Okay, so dy dt1 means dA dt, dy dt2 is dx dt, dy dt3 is dy, the big Y here, dt, dy dt4 is dB dt. Okay, So here, dA dt equals negative A1 times Y times A Y1. So A is Y1 times X. So X is Y2. Okay, so that's the first equation. And then for the second one, dx dt. So dx dt equals K1. So K1 times A. A is Y1 times X. So X is Y2 minus K2 times X. So X is Y2 times Y. So Y is Y3.
Betul.
Yes, saya.
Dot star tu maksudnya apa
Okay, so dot star means multiplication for element-wise matrix. Okay, so dot star is element-wise matrix multiplication. So contohnya matrix tu so let's say kita ada matrix 1, 2, 2, 3. Ni matrix A, and then matrix B 2, 4, 1, 3, apa-apalah. Okay, so kita nak multiply 1 dengan 2, 2 dengan 4, 2 dengan 1, 3 dengan 3. So meaning that kita nak element wise multiplication. Setiap elemen sini kena multiply dengan kedudukan yang sama. Dua ni multiply with the same position of element. So we use dot star. So A dot star B. So if you use only A star B, then it becomes the regular matrix multiplication. Meaning that yang kena tahu 2 darab 2, kena tahu dia punya dimension. Dan sebab ni sama, then baru boleh multiply, matrix multiplication. So this is regular matrix multiplication, okay? And this is element wise. Okay. So untuk ODE dalam MATLAB ni, dia sentiasa element wise, okay? So kalau kita buang dot ni, dia akan assume kita nak buat regular multiplication. So sometimes it can give error, okay? So to avoid error, just put dot star for each multiplication. But for K here, K1, so K1 kita tak letak dot sebab K1 is a constant. So we don't need to put dot. But you can also put dot, okay? Just as a measure of macam berhati-hatilah, langkah berjaga-jaga. Apa tak bahasa Inggeris, langkah berjaga-jaga.
Precaution, sir.
Precaution, gitu. Saya grad Malaysia je. Okay, so let's continue. So for the third equation, dy dt, so dy dt 3 equals K2. So K2 times X, so X is Y2 times Y. So Y is Y3, okay? Minus K3 times Y. So Y again, it's Y3. And then lastly, dB dt equals K3 times Y3, okay? So dah siap dah function ODE. So the important part of this kind of question is to have your ODE function correct, okay? Kalau ODE function betul, dia ada markah banyak lah kat situ. Sama macam belajar dalam automatic control, you have to have your free body diagram correct so that you can get the right transfer function. So here you punya function dy dt mesti betul, mesti tulis equation ni dengan betul, barulah dapat solve guna calling function tadi. So example here, kalau continue slide seterusnya, dia bagilah the values for K1 and K2 and K3. So tulislah dulu K1 berapa. So K1 is 0.1, K2 is 0.1, and K3 is 0.05. Okay, so lengkap lah. Okay, yang ni dah lengkap lah kiranya. So save, and then we write the calling function. Okay, so the first thing you need to have in your calling function is your initial condition. So initial condition equals, so since you have 4 ODEs, so you must have 4 initial conditions, okay? So the first one is A naught equals 5, so 5. And then X naught equals 5, also 5. Okay, 5, okay, ni tertinggal. So 5, E, 5 times 10 power negative 4. So 5E4. Okay, for Y naught is 1 times 10 to the power of negative 5. And for B, it's 0, so 0. After that, you must have your time span. So time span. Alamak, tak bagi kat sini. What happened? Ada contoh tak? Time span ni kita letak je lah berapa. Okay? So in exam, it will be given. Don't worry about that. Assume dulu. Okay, so after you have your Y naught and time span, then you can write your solver, ODE solver, ODE 15S, and then call your ODE function. Put your time span, put your initial condition in there. Save. And then we can try tengok betul tak. Okay, so you get 4 column of Y, okay. So this is Y1, Y2, Y3, and Y4. So the question, okay, so maybe we can try plot each of the Y first, okay. So plot T versus Y1. So we put it blue color. And then T versus Y2. We put red color. And then T versus Y3. Green. And T versus Y4. Yellow. Oh. So we can try run the function again. No. Okay, so we get some graph. So dekat sini nampak macam kecil sebab time range dia besar. So we can reduce the time range. Maybe kita tukar time span dia until 200, okay? So this is your answer for question example here. So dalam exam nanti kalau nak hantar jawapan tu letaklah label, okay, legend dia. Boleh adjust kat sini. Why this is X. Y B. Okay, so untuk plotting macam mana nak adjust coding untuk plotting, korang kena explore sendirilah, okay? And then you can put y axis. So we put x axis first. So x axis is time. And then for y axis is the chemical concentration. So untuk yang ni explore sendirilah nak buat macam mana, ada coding dia semua, okay? So the question here, time range from 0 until 100 seconds. Okay, so we can also plot y versus x. Apa jadi kalau plot y versus x? So plot y. So yt ialah y3, okay? So y3 is, you write like this lah, okay? Y double dot 3, okay? So this represent y versus x. So ni x axis, so x axis versus y axis. So y2 is your x, so y3 is your y, okay? So try plot apa jadi? Dapat macam ni, tak tahu apa kegunaan dia. And then you can put label. Okay, ni example je lah. Okay, so any question before we proceed?
No, sir.
Mesti Zaim kan?
Bukan saya. Bukan ni saya, sir. Tokan stiker.
Apa dia?
Tokan stiker.
Kuatkan speaker.
Bukan. Tokan stiker. Tokan stiker.
Tokan speaker.
Ha.
Bukan vacuum, bunyi komputer. Okay. Okay, kita pergi balik ke example Windkessel model. Okay, so Windkessel model ni exercise dia, okay? Saya pernah bagi soalan test Windkessel model, menggelupur, tak boleh jawab. So tak nak bagi dah, trauma. So kita tengok soalan ni sebagai exercise. Okay, so Windkessel model was first introduced by Otto Frank. Otto Frank siapa lah? Tak kenal. So physiologist masa tahun 1899. So tujuan, the purpose of Windkessel model is to study blood flow or fluid flow, okay, in the arteries. So our body is very complicated because it has a lot of blood vessel, a lot of direction of blood flow. it can flow to the brain, it can flow to the feet. The blood is pumped from the heart and then it can flow everywhere in the body. So kalau kita nak buat finite element simulation of the whole body, maksudnya nak solve dia tu kena guna komputer yang super power lah. Super power maybe yang sangat-sangat besar sebab nak modelkan satu badan kita ni. So macam tak logik lah. Zaman dulu tahun 1899 pun tak ada komputer yang macam tu. So they try to simplify the simulation by using electrical components to represent blood flow in our body. So to represent blood flow, they use electrical current representation. So they represent blood flow using electrical current. Okay. So electrical current is equals to the flow of fluid. Okay. So current is equivalent to flow of fluid. And then in the body, in the blood vessel, you also have resistance, blood flow resistance. So our blood vessel has maybe valve, for example, maybe ada lemak ke dalam badan kita. So all of this can be assumed as a resistance or something that resists the blood flow. So to represent that, we can put resistor to represent all the lemak dalam badan kita. And then also we can model the vessel wall contraction or stiffness. We call it compliance by using capacitor. So capacitor can be used as a representation for our blood vessel compliance. So compliance ni contohnya macam pipe getah. Kalau kita buka air laju, so pipe getah kita macam bergerak, macam sebab laju sangat pressure dalam air. So pergerakan pipe getah tu lah the compliance of that pipe getah. Okay. And also in our blood vessel also we have a blood flow inertia. So inertia can be modeled using inductor. So dia tukarkan all this blood flow resistant to blood flow compliance into electrical components representation using resistor, capacitor, inductor. So example here macam dekat model jantung ni. So siapa buat FYP model jantung, nanti kenalah modelkan benda ni. So ni example dekat aorta. So siapa yang buat aorta pandai-pandai lah. Nanti modelkan. Buat sendiri Okay. So the simplest Windkessel model that we can learn is by using 3-element Windkessel model. 3 element bermaksud ada 3 komponen dalam electrical circuit tu. So here you have R, small r here, and you have capacitor, and you have big R, resistor. So the current is represent the blood flow. So current represents blood flow. The voltage at the nodes. So dekat setiap node ni ada voltage. So voltage tu represent the blood pressure. So blood will flow from high pressure to a lower pressure region. So sama macam current, okay? Current pun flow from high voltage to low voltage. So untuk derive ni kita guna KCL, KVL. Ni subjek EET yang korang fail tu. So KCL, KVL, kita derive the current and the voltage. Okay, so kita try dulu codekan equation ni dalam MATLAB. Okay, MATLAB lagi. Okay, so the first equation says I equals UC over R plus C DUC over DT. So equation ni pelik sikit. Dia tak start dengan D over DT. So what you need to do is you need to rearrange your equation, okay? So the equation start with I equals UC over R plus C DUC DT. So you need to rearrange, okay? Rearrange your equation. DUC DT equals I minus UC over R. So kat sini ada C. So kena divide by C, okay? So I divided by C, UC divided by RC, okay? Okay, so kita tulis dalam MATLAB code how to code this equation. So dy dt equals I over C minus Y over R times C. Okay, so dy dt is duc dt and y is uc, okay? And then kat sini kita tak ada I. So I is given by the second equation here. So kena tulis balik lah untuk I. So for I it's U minus UC equals IR. So we write I equals U over R minus UC over R. Okay, tulis balik. So I equals U over R minus Y over R. So UC is Y, okay? And then kita tak ada the value for C, R, and C here. So dekat next page, okay? So R equals 1. So usually kita ignore the units, okay? C equals 1 and R equals 0.05. Oh no. Oh, ni tak ya. Okay, ada kesilapan sikit. So the I here, I is given by the sign function. Okay. So I ada sign function here. Okay. So this is your ODE function. So say first. So I dalam bentuk sign function. So kita tak boleh tulis I dalam ODE ni kita kena tulis I dekat the calling function. Okay. So let's write the calling function. Okay, so the first thing you need to have is the initial condition. So y naught equals here, y naught, you see not, you see at time 0 equals 0, and the time span is for 0.8 second. So time span from 0 until 0.8 second. Okay, so kat sini kita kena define I. Macam tu ke? Oh, kena define dalam ni. Oh, damn it, Jamil. Apa jadi dengan kau ni? So, I, sebab I ni kena guna if else lah, okay? So, if time is bigger than 0 and time less than ES, else. So, TS, kena define TS. So, TS equals 0.3. So, TS 0.3. So when time bigger than 0 or less than TS, so I equals I naught times sine phi times T over TS squared, okay? So square so we have to define I naught equals I naught pun tak bagi. Apalah Jamil. So assume I naught equals 1. And then else I equals 0 for other time range, okay? So I equals 0. Save balik. And then in your calling function, you can write the ODE solver. So call the ODE function, time span, and y naught. Save dulu. So we can plot T versus Y. Dapatlah graf dia. Tak menarik pun. So Windkessel model selalunya kita run untuk tempoh masa yang lama. Kita cuba je, okay? 10. Ni tak ada apa-apa berlaku. So kita revert balik. Okay. So the idea of this exercise is to ask you to write if else, okay, dalam ODE function. Sometimes the parameter can be in the form of if else, okay. Tapi dalam test tak ada kot. Ni just exercise. Sebab soalan macam ni terlalu luar biasa. Especially kalau korang tak pernah tak biasa dengan MATLAB.
So maknanya yang tu tak masuk test lah.
Tak masuk, tapi assignment ada kot nanti. Assignment pun nanti lambat lagi minggu depan kot.
Okay sah.
Okay, so yang ni tak penting. Okay, so yang ni kita sambung minggu depan lah, okay. The application of ODE in neural activation. So yang ni famous, one of the most famous models, ODE models yang memang digunakan dalam banyak application, okay. So Oskin dengan Asli ni dia orang ni menyusahkan hidup lah sebenarnya, okay. Sebab dia orang create this modeling for neural activation. Tapi dia orang menang Nobel Prize, okay, 1963. Mathematics je, okay. Boleh menang Nobel Prize. So kalau korang bercita-cita nak menang Nobel Prize, bolehlah jadi macam dia orang. Okay, so that's it for today. So we will continue next week on Thursday. And oh yeah, your group project, make sure group tu regroup balik sebab kita buat 4 orang satu group, okay? Maksimum 4 orang. Kalau nak buat 3 orang pun boleh je, tapi try 4 orang lah, okay? And then maybe kita brief, I will brief to you about the project next week, okay? So assignment 1 hantar minggu depan. Dekat kalam nanti saya buat dia punya submission. Okay, itu je for today.
Okay sir, thank you sir.
Okay, bye-bye.
Assalamualaikum sir.
Okay sir, thank you sir.
Thank you, sir. Thank you.
Thank you sir.
Thank you very much.
Thank you sir. Best belajar
Main macam ke tu? Main macam pop-pop ke?
Thank you sir.
Okay. Thank you. Popcorn.
Okay sir.
Masak popcorn ke? Aduh, bawah. Bye, thank you.